All right, we're almost at the end of this first section of material, but so the rest of the notes file for section 1.1 is kind of just this one heading labeled more examples, and it's not kidding, there are a bunch of them. I'm not going to hit each and every one of them. I want you to play around with some yourself. I am, of course, willing, to answer questions that come up. You can shoot them to me via email or what have you. Anyway, so the first example I want to take a look at here deals with a building depreciating for tax purposes. And we're actually given an equation that describes this, which is an upside because we don't have to build an equation like we did with Joe's investment portfolio. So the thing we've got is the following. So y equals 565,000 minus 1,130x. And we're told y is how much the building is worth tax-wise, and then x is the time in months from whenever we start paying attention to this. So y is our value, x is our time frame. Like I said, this is where one of those cases where you may want t for time, v for value or something, but we'll go with the variables as they're given. All right. So the first question we're asked is, how long does it take for the building's value to drop to the highly specific value of $336,740? So remember, which variable is the value in this instance? That's y. So here, y equals 336,740. Camera is not focusing. That's going to be a bit of a bother if it stays like that. Okay, I'm trying to give it a moment to refocus before I keep scribbling. All right, so try to center up. There we go. So that's my trick for myself. Why am I telling you this? Anyway, so y has to be 336,740. We plug that into the equation, and then we just need to get x by itself. So 336,740 equals 565. 000 minus 1130x. Now to get x by itself, we've done a whole bunch of this at this stage, so I'm going to kind of sweep them, the calculations together rather than laboriously writing it out bit by bit. We need to subtract the 565,000 over here, and then we need to divide. So now once that guy is gone, all that's left is negative 1130x, and then we need to divide by that coefficient. So. And technically, yeah, I'm moving x over to the other side of the equation. You can flip them, that's fine. Don't flip inequalities like that unless you need to, but yeah, equations, yeah, that's... Yeah. Anyway, so we have 336,740 minus 565,000 divided by negative 1130. If you needed to do that in two separate calculations, that's fine. Again, no judgment here. But if you're typing this into your calculator all at once, be careful on this front. Make sure to include parentheses in the top of that calculation. So if you don't, your calculator will divide 565,000 by this 1130 and ignore the first bit. Like I said, those parentheses would be important if you did that. Now, in any case, once you work out the calculation here, feel free to press pause if you're typing it in yourself or what have you. We get 202 months before we reach this particular value. And so that's letter number A. Letter number B says, after how many months is the building totally depreciated? And then it asks us to convert that into a time in years. All right, so for this guy, totally depreciated means the building is worth nothing for tax purposes anymore. I don't know if that actually happens. I'm not a tax expert. But so instead of plugging in the weird 336 number, we're going to plug in y equals 0. So we have 565,000 minus 1130x. That's still where we had it. Now it's the same process. We just subtract over the 565,000, divide by the negative 1130. So negative 565 000 divided by the negative 1,130. If you work out that calculation, you should get 500 months. So that's the number of months. It does ask us for a time in years. You may end up, kind of pausing. Hopefully not too long, but how many months are there in a year? That's right, there are 12. So if we divide 500 by 12, we get about, it's got a like a repeating decimal, but 500 months on the nose, or approximately 41.7 years. So that's, that's this depreciation problem. All right, one down. Let's take a look at the next guy. So in this next example, we've got like a company that's selling sweatshirts, and they have worked out what they call their cost and revenue function. So you may be wondering, what does that mean when he talks about functions? I promise we'll get there. For now, just kind of swallow the equations. I promise this C parentheses X thing makes sense soon. So we have cost is 15x plus 12,425. R for revenue, hopefully that stands to reason, looks like 2,500x. And I forgot to, no, I do have the x. Okay. Now, we want to know, this is, like I said, x is the number of boxes of shirts, not individual sweatshirts, so it feels a little more realistic. So we want to know how many boxes our company needs to sell in order to break even. So, looking for these things we call break-even points. You've probably done this before. I don't like making break-even one word. I don't want to put a hyphen in it if I did that. So if we want to find our break-even point, so in order for us to break even, what's got to happen? Well, we're not making any money at all. So sort of like the cost and the revenues, they're going to balance each other out exactly. So, all right. Give me just a sec here. The camera is not wanting to focus, so I'm going to press pause and see if I can get it to, come back into focus. All right, we're back. I'm really sorry about that. That's kind of aggravating, but I don't know what else I can do about it right now. So please bear with me. Don't hold it against me much. So to break even, cost and revenues need to balance out precisely. So you can say C of X equals R of X, or you can just take these two things they're equal to and just go ahead and set them equal to each other. So we have, or heck, you could just write C equals R if you like. So 15x plus 12,425 equals 2,500x. All right, so now from here, we subtract over the 15x because we need all of our x terms on one side of the equation. So that gives us 12,425 is now by itself on the left-hand side. 2,500x minus 15x is the sort of odd-looking 2,485x. All right, so now to get x by itself, we got to get rid of the coefficient. We do that via division. So we have 12,425, and then we divide that by the 2,485. And you work out the arithmetic there. That gives us a, seems like a promising number. We start making profit after we sell 5 boxes of sweatshirts. Doesn't actually, as you say, okay, that's like 500 shirts that we've sold. I don't know how reasonable that is. Maybe we're working for like multiple schools, right? Anyway, so there's our cost revenue example. We're going to come back and visit some more of these guys, actually see where these like cost revenue functions come from later on in the chapter. But for now, I want to go ahead and move on. We've got a couple more examples I want to take a look at here. All right. So the problems on the next page, almost all of them, except for the one at the very bottom, end up talking about percentages, like percentage of a number or percentage growth or tax or something like that. I'm going to take a look at the one that talks about the sales tax on a computer. So if you look at, this is example 4, if you're following along in the notes file, we say we bought a computer and it cost $22.47. That's with the tax factored in. But like our receipt's gotten damaged or something and we can't see how much of it's actually tax. So we're trying to figure out how much is tax, which I guess technically, why don't you go back to the store and ask for what the sticker price was? I don't know, just roll with it, okay? All right, so now, the problem is you might be inclined, well, can't we just work out 7% of that 2247? That'd be great if it would work, but no, you can't. That's not gonna work out the way we need it. The idea is, whatever the sticker price is, so call the price without tax, oh gosh, the camera's blurring again. So call the price without any tax X. All right. So now the sales tax is calculated as a percentage, right? According to the problem, it's a 7% sales tax. So So whatever it said on the sticker, which is x plus the tax, which is 7% of x or 0.07x. I'm going to step closer here so this thing comes back into focus. Come on, work with me here. Okay. All right, so x plus 0.07x is 2247. We can add those together. Remember, there's sort of an implied 1 in front of this x. So, all right, so now 1.07x is equal to 2247. To get x by itself, we do the division thing. We've been doing this a lot. So divide 2247 by 1.07. Come on, focus. All right, so when you work this out, step a little closer, see if that helps. All right, so what that should end up giving us is $2,100. Okay, so waiting to see if it comes back into focus. It's still a little blurry. I'm going to press pause. That's going to get really tiring. I do apologize. So 2247 divided by 1.07 is 2,100. Now the catch is, that's not our answer. Good Lord, we hope we didn't pay $2,100 in tax. Remember, that's the sticker price. We've got to subtract that away in order to get how much tax we actually paid. So 2247 minus 2,100, or 147 bucks. Okay, so that's that guy. So when you have percentages of growth or decay or something like that, we talk about pay cuts and raises in the next example. Remember, if it's not just talking about a straight percentage, a growth or a reduction, remember, just like subtract away from a baseline of 100% or just 1. All right, so there's one last example I want to take a look at in this section, and it's the very bottom one there, talking about like car rentals. So one car company is charging 35 bucks a day, another one charges less per day, but there's a flat fee built in. We want to know how many days, how long do we have to go before it's cheaper to have rented from the second company to pay that extra fee. So in that last example, we can kind of line up the two quantities and then set it up so that the inequality is the way we want it. So we want the 35x, that's the first company's total payment. If we say x is the number of days we rent the car, is greater than 22x plus the flat fee of $65. All right, so we want to solve that guy for x. 35x is greater than 22x plus 65. Subtract over the 22x. 35 minus 22 is going to give me 13, so we have 13x is greater than 65. Divide both sides by 13 to bring this home. 65 divided by 13 gives me 5. Note that we're dividing by a positive number, so we don't need to flip the inequality symbol around. So keep in mind when you report this, it says it's cheaper from the second company. Not the same, specifically cheaper. That's why I don't have an or equal to there. So if you were reporting this, 5 days doesn't cut it. You need to go out 6. You need x to be greater than 5, so 6 or more days. So if you had said more than 5 days, that also does it. But so that's our answer there. Okay, deep breath. So I was pushing up against the end of the video to get in all of the examples that I wanted to take a look at here. All right, so that's section 1.1. As I said, I have skipped over a fair number of these exercises to give you something to practice on before you go into the homework where it's kind of graded and stuff. So if you got questions, let me know. I'll be happy to answer anything that comes up. And we're done with 1.1. Let's take a look at another section next time.